Hello everyone! So there's a fine-tuned LTX videos model I want to show you guys. This one is better than the LTX base model. Well, for consistency, it's very easy with diffusion transformer architecture. Consistency isn't really an issue anymore for DTAI models, so I won't spend too much time on that, like, oh, this is so cool, I can create consistent characters. Rather than that, we're going deeper to analyze how a fine-tuned model performs. We're talking about fewer deformations, better coloration, and higher motion quality, and see how a real fine-tuned models outperform the base LTX model. Now let's check it out. Here, we've got some very cool animations, even over 10 seconds long, using a Pixar-style character. We've got these two couples in a bedroom, having their fun moments. So far, all the elements in this animation are working very nicely. With a very small-sized AI video model, we can produce something like this. Let's take a closer look. This model is from Dream Diffusions, created by Dice. He's one of the top AI model developers, popular back in Civet AI. For some reason, he doesn't like that platform anymore, so he's no longer active there. I've talked to him and we've checked out his work. The LTX model is very friendly for local AI video generation. It's easier for people to pick up and it runs faster than other diffusion transformer models. This model is capable of text to video, image to video, and video to video, all in one small package. The file size is about 5 GB, which is very similar to the LTX base model, version 0, 9.1, which is also around 5 GB. We've discussed this before. These LTX models have file sizes similar to SDXL checkpoint models. With just a few gigabytes, we can produce something like this Pixar-style character. Dice has also created a lot of other animations, some weird, some funny, using LTX, but of course, we can't just rely on one workflow or one AI model to do everything. We need to combine different AI tools like upscalers, text-to-speech, and other AI models to improve the quality. You can try this with other AI models, not just LTX. Now, back to ComfyUI. You can download the model I just showed. The link is in the description below. It's from cart.ai. You can download it by clicking the download button. It's very self-explanatory. I don't think I need to explain how to download, right? Once downloaded, save it in the checkpoints folder under your ComfyUI/models/checkpoints directory. As you can see, I've already saved mine here. This is the Dream Diffusions videos 3B, about 5 GB in size. You'll also see the LTX videos 2B, which is about the same size as the 0, 9.1 LTX videos model. The oldest LTX videos model is about 8 GB, but I think I'll delete that soon because I have too many AI models on my hard drive right now. So yeah, I'll delete that one, the 0. 9.1 is good enough for what I need with LTX. Now, back to ComfyUI. Once you've downloaded the model, you can load it using the load checkpoint node. You'll see the model listed along with other subfolders. I've got SD 1.5, SDXL, and some other commonly used checkpoint models saved in the checkpoints folder. Now let's go back to the ComfyUI workflow. This is a very typical image-to-video workflow based on the module I've been using for my LTX Video Gen Suite version 2. I've published this workflow in some of my previous videos. Basically, it includes text-to-video, image-to-video, and start frame, end frame options. You've got video sound effects and video extensions to finish the video and display the result at the top. I'm not going into too much detail about this workflow here. I'll link the full guide in the video description. I'll keep updating it as I add more features that are suitable for LTX video generation. But here, I've selected only the image-to-video module. This is one of the benefits of using a modular workflow design. You can highlight everything with your mouse, copy it, and paste it into an empty workflow. This is the flexibility of the modular workflow design. I can focus only on running the image-to-video features of LTX videos and test how it performs. Here I've already tested some videos before, but I want to test them again together. This time I've got this Disney character image, and of course you guys will know who that lady is. Coming back to the text prompts, we've got some text generated from the image using Florence 2 to create captions. I've replaced some image-related keywords with video-related ones to make it more suitable for LTX videos, but I found out that the text prompts from Florence 2 aren't detailed enough to generate good results with LTX videos, so what I did was use DeepSeek version 3, one of the recently popular language models, to enhance the prompts. I instructed it to convert image prompts into video prompts. Some of the creativity comes from the AI in converting the prompts, and some of the results are too long or have too many events in the context. So, sometimes I have to review and ask the AI to shorten the text prompts. Some of the good ones come out like this, and these lengthy text prompts perform very well in terms of the generated results for LTX videos. This is because LTX videos has a very small parameter size. As you can see, not only is the file size small, but LTX itself has a small parameter size. We're talking about 2 billion parameters. When you compare this to other diffusion transformer AI video models, which have over 10 billion parameters, or Hunyuan videos, which has around 12, 13 billion parameters, LTX is tiny. So with such a small parameter size, you need to use more detailed text prompts to instruct the AI. That's just how it is. It's not as smart as larger models, so you have to guide it more. Once we've got the context, we can create more detailed text prompts using language models like DeepSeek. Again, you don't need to use DeepSeek specifically. If you have ChatGPT, Claude 3.5, whatever you prefer, you can use that. Just make sure the AI understands that you're converting image prompts into video prompts. Type in whatever you want the AI to do, and that's good enough. I won't go into too much detail about prompting with language models here. The main purpose is to test the DICE fine-tuned LTX model. So let's try it out using this model, and you'll see the difference. I'll also generate another result using the LTX base model for comparison. Here, I'm using STG guidance, which works a lot better for LTX videos in terms of stability. All the elements are less likely to deform, and the coloration performs better compared to using CFG. You can check out my previous videos where I've talked about this in more detail. Let's try this and go through the generation process. We'll see the results side by side. Okay, so we've got the generated result here. This is pretty much like the introduction I showed at the beginning of this YouTube video, the 10-second video. Why 10 seconds? Because I'm using my full workflow to extend the video length like here. That's why we got 10 seconds in the earlier example. For this demo, I'm generating about 5 seconds of video, which is enough to see how the animation performs using the Dream Diffusion's model. Here, I'll mark this result as coming from Dream Diffusions, and I'll bypass this one just for labeling. Then, I'll clone another video and use the LTX base model so you can see the difference. I'll use the load checkpoint node and select the LTX video 0, 9.1 checkpoint model. This will be dragged in here so you can easily see the difference between the two video players. I'm not changing any other settings, dimensions, text prompts, etc. Everything stays exactly the same. The only difference is that we're using the base model this time. Let's see how that result looks. Okay, so both results are here. As you can see, the base model generations, both video models' results, are pretty much the same this time. Well, first of all, the fine-tuned model is based on the base model, so the overall motions are very similar. But when it comes to the character's motions, like how the eyes look back and forth, the base model doesn't have as much dynamic detail. It might have the initial eye contact, but then it pauses or just stays static for the rest of the video. In contrast, the fine-tuned model has more range in facial expressions and more motion overall. Now, in terms of quality, they're very similar because I'm using STG guidance. If I weren't using STG, it would be a different story. So let's try this again without STG and see how it looks. Okay, so here's another test where I'm using a basic image-to-video workflow in LTX. As you can see, I'm only using native nodes here, no STG, just CFG, which is the normal practical way of running animations. I've tried one image like this using the base model. I've placed the base model checkpoint here underneath the video player. As you can see, there's less motion in the base model's generation. It should show the woman walking forward smoothly, not in slow motion, but the outcome isn't as dynamic or cinematic as I expected. That said, the consistency and elements aren't affected, so I'm going to try something else using this image, a man walking in a back street during the rain. There should be more motion in this one, and we'll see how it looks using the base model. All the settings here are the default native nodes in ComfyUI. You can use this without downloading any custom nodes. This is a basic way to test the AI model. While I'm talking, the generation has already finished. You can see the guy walking in the foreground, the background is blurry, but the main character is moving. However, there's less motion for the main character. He should be walking a few steps, but instead he suddenly turns around, which doesn't make much sense physically. Also, the water on the ground, since it's a rainy scene, doesn't have much reflection. Only the guy is walking on the blurry side and the background shows some water with reflections. Now, let's see how this looks using the fine-tuned model. But I won't set my expectations too high because, well, it's just a fine-tuned model. It's not going to be a 100% improvement. If someone tells you it's a 100% improvement, that's a lie. So I'll create another load checkpoint node here and connect it to the LTX Dream Diffusion's video, the fine-tuned model. We'll check that out and see how it looks. Okay, so both results are generated here. Let's do a side-by-side comparison. As you can see, the disconnected one is from the LTX base model, and the one connected to the image line is from the Dream Diffusion's fine-tuned LTX. Which motion do you prefer? I'd prefer the Dream Diffusion's motion in this case because it makes more sense. Both people on the screen are walking forward in the same direction, which aligns with the image's movement. From the initial frames of the image to video, you can see it's more logical to assume that the two guys are walking forward. The fine-tuned model captures this motion better. Of course, I've used the same prompts for both models. Cinematic scene of a man walking down a wet, rainy, silky street. As you can see here, the language model also described the scene as rainy, with a silky wet floor. You'd expect some raindrops, but LTX isn't detailed enough to render raindrops like Runway or Clean AI can. But of course, for a small model like this, only 3 billion parameters, it's impressive that it can even get close. It's, acceptable for the consistency, coherence, and style of the generated result. Now compare that with the base model, which is marked with the red box here. You can see the motions of the character don't make sense, right? The character just stands there and then suddenly turns left. The logic of the scene doesn't follow the physics of how things should move. So this time I'd prefer the Dream Diffusion's fine-tuned model for this image. Now, let's try another example with more exciting motion and movement. Okay, so here's another example where I've loaded an image from another folder. It shows two cowboys riding horses in the middle of the desert. This is the result from the Dream Diffusion's model, and it's pretty clear. Even though it's using CFG and not STG, it's able to maintain coherence for all the objects. At least the horse's legs aren't broken or disappearing, which sometimes happens. Now compare that with the second example, which is from the LTX base model. Here, the horse suddenly goes from 4 legs to 2 legs, and there's some dust and sand floating around. The guy at the front starts to disappear. Yeah, that's probably due to the dust and sand floating in the air effect, or maybe it's because there wasn't enough memory to render that character properly. So far, I like DICE's Dream Diffusion's model because it creates pretty coherent styles for the characters and the overall background. This cowboy-style scene looks great. Okay, and here's another example I'm working on for an upcoming short movie. One of the scenes is being tested in LTX. Again, the same node positions are used here. Obviously, you can see the Dream Diffusion's model has been fine-tuned. The timing of the character's motions, the details, like the hair floating, and the camera pan are smoother. It's not as sudden or jarring as the base model's output. In the base model, the explosion behind affects the character at the front, causing them to melt, which doesn't make sense. But with Dream Diffusions, while it's coherent and there's no deformation in the scene, some prompt instructions weren't fully followed. For example, the explosion from behind wasn't fully rendered, so there's still some room for improvement in this generation. But overall, I think most people would choose the Dream Diffusion's result here. So yeah, check it out, guys. You can go to the link provided in the description below. You'll find everything you need there. Download the models and learn more about DICE's work. He's also done some fine-tuned models for Pony, Flux, and SDXL, and his SDXL fine-tuned model, the image generate result, which look like Flux quality. Those are very interesting. You should check them out. He's actually training AI models rather than just do model merging, like a lot of so-called models on Civit AI. Some of those models are labeled as trained, but they're just merging. That's why when you use multiple LoRa's, you'll often see the image quality degrade due to poor training and settings from those merger model. All these fine-tuned models are available to check out. So that's it for this video, and I'll see you guys in the next one. Have a nice day. See ya.